Okay, we're recording. Okay, so good morning. Today I'm going to complete 3D Mohr Circle. Then we're going to do an example. Okay, hopefully I can finish the example before it ends this morning. Okay, for 15 minutes. Okay, let's not waste time. So the next stage we're going to look at is condition number 3. So just to recap, we were looking at 3D Mohr Circle. Okay, so we have our transformation. So we have our X, Y, and Z. Then we have our element. Okay, I have a lot of questions regarding, some students were asking me in an actual shaft or any structure, where is the in plane? Don't worry about that. We'll do that in the afternoon. Okay, we'll do that in the afternoon. So this is our element again. So this is our stress X, stress Y, and stress Z, the biggest area, right? So this is our in plane. Okay, the rest are our out of plane. Okay, out of plane. So in condition number 3, the last condition is where we have stress X is smaller than stress Y, smaller than stress Z. So one of our students asked that yesterday. And we're going to take this condition where all are positive. Okay, so we have a condition where all are positive, right? Then we're going to draw again Mohr circle. So there is our normal stress. Over here is our shear, clockwise rotation, anti-clockwise rotation, and this is our normal stress. So as what we were given based on this condition, right? So we have, this is our stress X line. Then this is stress X. Then we have our stress Y line. Okay, so this is our stress Y. And then we have our stress Z line. Okay, so this does just satisfy the condition where stress X is smaller than stress Y is smaller than stress Z. Okay, so we will label this X, Y, and Z. Okay, so from here, we know that this over here, this point over here is our point X, point Y, okay, point Z. Okay, so we can start constructing our circle for the XY plane. And you guys by now should know why is this called XY plane. Okay, so this is our first circle. All right, so this circle represents, why XY plane? Because it touched the X point and the Y point over here. So this is the XY plane. And the XY plane happened to be in plane. And we spoke about this yesterday. If you look at the shearing stress, right? So this is the shearing stress. Oops, there's our shearing stress. So this is our stress max in the XY plane. Okay. And then we look at the next one. Okay, so the next circle that we're going to construct is YZ plane. So this belongs to our YZ plane. So this is the one that's out of plane. Okay, if I zoom out, you can see based on the diagram, right? Your YZ plane. So where is your YZ plane? So YZ plane. So this is your YZ plane, right? This is your YZ plane. It's our plane. Okay. So over here, this is our shear max, and it's on our YZ plane. Okay. And then, as I said, 3D Mohr circle is 3 circle. Okay, not you don't get a sphere. So the last circle that we're going to have, so 6, 8, 4. Right. So because it touches the X point and the Z point, I repeat again, it touches the X and Z point. So for this case, this belongs to our wrong color. This belongs to our XZ plane. Okay, so we also know our XZ plane is our out of plane. So from here, we are also aware that this will be our tau max. Okay, this will be hold on. Right, so this is our tau max for our XZ plane. Okay, and this is the biggest circle. Right, you can see that that's the biggest circle. So this will be our tau max. Okay, and our tau max over here, this tau max over here, it is out of plane. Okay. So whenever you see out of plane, you need to do 3D analysis, okay, or use 3D Mohr circle. Yesterday we looked at a case that in fact you don't need to use 3D Mohr circle, you can use 2D and your answer will be the same. So over here you can see that tau max will be equal to stress Z minus by stress X divided by 2, right? So if we were to write this, we can also write this is when we have stress max or stress Z. Stress Z is your stress max, and stress X the stress mean. We can rewrite the equation where the shear in max is equals normal stress max, normal stress mean divided by 2. Okay, so this is only true, right, if and only if stress X, Y, and Z, okay, are not equal to 0. They are all what? Positive. Right. Any questions so far? Okay, so this is now yesterday we spent an hour. Now we just refresh what is 3D Mohr circle, so it should be quite clear for all of you. Anyone, any questions, please? Anyone? Okay, so I do see a question popping out. So when the value Z is between X and Y, 2D is enough. Yep. Okay, yeah, absolutely right. Okay. So that case, yeah, that case, yeah, you always you can use 2D Mohr circle. Okay, right. So let's look at one example. Yeah, let's look at example number. So this example that we're going to do. This example that we're going to do is this element is not at its principal plane. Let me elaborate. Okay, so this is so let me draw the transformation. Right, so this is our element. Right, So we have a 120 megapascal, right? And then we have a 60 megapascal. And then we have a shear, okay? This is equal to shear YX. And this will be equal to 30 megapascal. And then we have a normal stress, okay? Stress Z. And stress Z is equal to stress Z is equal to, so I would say is equal to minus 20 megapascal. Or I'll put it to 20 megapascal. And I will put that is going into compression. Okay, I'll put it. So the first thing we do, we label. So what is unique about this question? Okay, what is unique about this question is we are going to that we have a shear, right? We have a shear, and then we have three X, Y, and Z. Normal stresses are not equal to 0. Okay, so we are going to find. You're going to find we like to find the principal stresses, the maximum principal stress, okay, and maximum shearing stress. Okay, so we know that stress X given to be 120 positive. Stress Y is equal to minus 60 megapascal. And then we have stress Z is equal to minus 20 megapascal. And then we know that shear XY is equal to shear YX. And this is equal to positive 30 megapascal. So this example, I'm more or less helping some of you to recap 2D Mohr circle also. Okay, so one stone kill two birds. One stone kill two birds, right? So now we start drawing Mohr circle. So I will start off with minus 80, 60, 40, 0, 20, 40, 60, 80, 100, 120. Okay, and this is our, I think I need a bit more. 140. So normal stress, and then we have our shearing stress. So this is our shearing stress. Element rotate clockwise, counterclockwise, and then I'm going to label to 100. Right, 20, 40, 60, 80, 100, minus 20, minus 40, minus 60, minus 80, minus 100, right? So we will hunt down where our, so we're going to label this as our point on Mohr circle X, Y, and this is Z, okay? So X is at 120, stress X is at 120. All right, so this is our stress X value, right? And then Y is at compression minus 60. Okay, so this is stress Y. And then Z is minus 20. Right. So this is stress Z. And stress Z point is easy to identify because it's compression and it has 0 shearing stress. Okay, so over here